this one. And this is a major topic, integration by substitution. As you all know, integrating is a little bit tougher than differentiating. And Skylar, you probably want to be here for this. And sometimes they don't integrate nicely. So one very powerful technique we can use is substituting. And there is, this is kind of a big chapter, but I felt like in one area I want to clarify in the book. I feel like it's a really important thing that the author kind of glossed over. At the bottom of page, where is this? 302. So check it out. Okay, thank you. The bottom of page 302, it says, some integrals whose integrands involve quantities raised to powers cannot be found by the general power rule. Consider the two integrals, and they have the integral of x times the quantity x squared plus 1 squared dx is 1, and the other one is the integral of x squared plus 1 squared dx. And I thought the author made a really good point here by saying some places substitution works and some places doesn't, but then he didn't go through and explain why. So I want to do that today. Skylar? Yes. Yes. So if you want, you can just pay attention and try to absorb it and get a little bit directly and then watch it later. You can. Now, obviously, you could expand this, and we'll do that afterwards. But for right now, let's do a substitution. So the author suggests letting u equal x squared plus 1. And usually that's a good technique, is to go inside the parentheses right here, because this is kind of a mess when you square it. Not really, but, it gets more complicated. Usually that's a good candidate to let u equal to. Sometimes it doesn't work, okay? So then here's how it goes. And you've all read this, but we'll go through it together. So du, the derivative of u with respect to x, would equal what? 2x, good. And then we would say that du equals 2x dx. So far, so good? Okay, now, let's check out what we have up here. I'm going to drag this down a little bit. I just thought this was so important, and they kind of glossed over, like, oh, yeah, this works. And then they didn't really talk about it. I need a different color. So right now we have u squared. And we almost have, we've got x dx, not 2x dx. Okay? Orion? Yeah, here we have u, and then this is squared. That's what I'm getting at. Maybe I need to extend that a little further. Orion. All of this would be u squared. Okay? So, we almost have it, okay? Because there's an x dx, we need a 2x. We can fix that, okay? We can do that by saying, okay, this is the integral. Let's just make it 2x dx. I'm moving it around a little bit, times x squared plus 1 squared, okay? Now, in order to make this 2x, what would I have to do to keep things balanced? Remember, it has to be x, but you can give stuff makeovers. What would I have to do to make this 2x legal? I would not. Great point. I would not. How about if I go like this? I'll back up a little bit, Kylie. How about if I go like this? The integral of 1/2 times 2 x dx. Can I do that? Legal? Tucker? 1/2 times 2? 1? That'd be 1, so it's 1x. So that's cool. And as you all know, then, I could say this is equal to 1/2 times the integral of 2x dx times x squared plus 1 squared. And really, you'd probably write this as x squared plus 1 squared 2x dx like that. Okay? Now notice my du was 2x dx and my u substitution was x squared plus 1. Well, okay. Right here, that's u. I have that right here. Yeah, that's u squared. And right here, I have 2x dx. Right. So now I can say that this is 1/2 times the integral of u squared du. And notice, these guys have to match. If you're doing this in terms of u, integrating with respect to u, then it has to be du. Okay? Those guys got to match. And now we're in proper form. I know this took a little while to get set up, but after you get into this, they'll go faster. Okay? So now, taking the integral of this, Orion, we're going to do that next. And the answer to your question is sometimes it's faster not to. Like, what if this was to the 10th power? That expansion would get ginormous. Correct. You don't have to do, that's a really good point Orion makes. You don't have to do substitution, but sometimes it's a lot easier too. And the whole point is being wise enough to know when to substitute and when not to. Original one. Okay? All right. And I'm not going to talk all day, I know, because this takes a while, but this is important stuff. Really, you know. So now let's do, oh, go ahead. Ian? It's still here. It's right there. No, but the x is still in this phrase. Is this expression right here 1/2 times the antiderivative of the quantity x squared plus 1 squared times 2x dx, is that the same as this? Yes. So it's still there. It's exactly the same because 1/2 times 2 is just 1. The x is there, the dx is there, and the original binomial squared is there. All right, so here we go. Skylar, stay with it, please. All right, now let's do the integral. Milo, help me out. The rest of these guys are scared, but I know you can do it. Sorry? Yeah, we're going to take the integral of this cat here. U cubed is correct. What's the coefficient? 1 over 3. 1/3 u cubed. Then plus c. Very good. Because it is indefinite integral or an antiderivative plus c. Okay, one more step and we're done. Milo, you're almost done. You've done great so far. We're almost there. Distribute the 1/2 gives us what? 1/6 u cubed plus c. Boom. Okay. As always. Oh, great point. Great point. That is a great point. C is a constant, so you can say half C or you can just say C. Since it's a constant, it really doesn't matter. You can say 1/6 u cubed plus C is equal to half C in essence because we don't know what it is. It's a good point. Okay? It exists, but yeah. Okay, so now, as always, we want to check it. Okay. Oh, I'm sorry. I'm not ready for that. We got to substitute back in. I'm skipping a step. Substitute back in. What was our u? Okay, so we had 1/6 times, no more u, x squared plus 1 to the third power plus c. And then we're done. Okay. And then, as always, check it. How? By derivative. Derivation. Okay? So let's take d, the derivative with respect to x of 1/6 x squared plus 1 cubed plus c. What do we get? Ian, help me out, man. It's a constant. It becomes 0. 3 times. Chain rule. X squared plus 1, whatever's on the inside, times to the power of 2. Thank you. Times 2x times the derivative of whatever's on the inside, chain rule. Okay, let's clean it up. Keep going, Ian. You're on a roll. No, be careful. 1/6 times 3/1. 3/6 times 2x, 3/6 times 2x times x squared plus 1 squared equals boom! Check it out, everybody. Check it out. What did we start with? X times x squared plus 1 squared. Boom. It works. Okay, nice. Nice. Now, and Orion's right. You can expand that and not use substitution. That's totally fine. Okay? But let's check it out. Let's check this one. Same thing, the author says. And this is the part that bugged me. They didn't expand. Let u equal x squared plus 1. Okay? Same thing. The derivative of u with respect to x equals 2x. Same thing. Du equals 2x dx. Yes, Ryan? Yeah, and I will. Okay, now, notice we have a problem. We have our u squared here. Okay? We have our dx. We have our dx, but what's the problem? Yeah, the 2x is nowhere to be found. So we'll say the conclusion is we're unable to use u equals x squared plus 1 as a substitution. And I think that's a really important point to hang on to. And it's okay. Boy, you did the old Japanese thing, fall down 7 times, get up 8 times. Will, your hair looks fabulous, but You really need to pay attention. Okay? The old thing about that is so true with substitution. Sometimes you're going to choose a wrong thing and you're going to go this far and go, oops, that's a bad choice. And you're going to choose something else. Well, because I do not have an X term here, I can't just generate one, and I can't make a nice, I've got to get this in some form of UDU, and I can't get it. Okay? I have to have it to where I can make it work. And because I'm missing a variable X, that is a bad choice. Okay? I wouldn't use substitution for this equation. I'd use the old Orion method and get, x to the fourth plus 2x squared plus 1. Well, not always, but I'll just say you have to be able to express it in terms of u and du only, like I did right here. Okay? Got to be able to express it in terms of u and du only. And without any other variables.
So that's why.
Correct. So that won't work. Okay? And, yeah. Now, Ryan, you asked me to scroll down to the bottom here. Yeah. And that's a major point. Okay. I think I've talked enough for today. Tomorrow, I want to give you some time to work on this. Tomorrow, I want to talk about what we do when we have limits of integration, because we're going to have to mess with this, but I think that would make too long of a video for today. We'll worry about this tomorrow, and for today, I'll give you some problems to work on that just involve this kind of stuff, okay? Next time on Calc Chat, exactly, okay.